Hello everyone. Today we will see the most important points in the chapter sterilization. What is sterilization? It is a process by which all viable microorganisms are removed or destroyed based on probability function. So this is the classification of sterilization. Sterilization broadly is divided into thermal and non-thermal methods. In thermal methods, as we know, there is dry heat sterilization, moist heat sterilization, combination treatment. For example, heating with bactericide is a combination treatment. Then fractional method, marginal method, and low temperature steam formaldehyde. Fractional method is nothing but as we do in tyndallization, we are heating the sample for sterilization for a specified period of time at a comparatively lower temperature than other methods for consecutive days. That is, the process is repeated more than once. We are doing it in a fractional manner, that is fractional method. Example is tyndallization. And the second method is marginal method. Marginal method, the name came from the questionable reliability of the process. That is, here we are using comparatively very low temperatures, for example, temperature in the range of 60 degrees Celsius, and it successfully brings about sterilization can be questionable. That is why the term marginal. And low temperature steam formaldehyde application. So all these things will come under thermal sterilization. Okay. Next is non-thermal methods. It can be classified into physical and chemical methods. In physical method, there is filtration sterilization and there is radiation sterilization. Radiation sterilization in turn is divided into sterilization using ionizing radiation. For example, gamma radiation, and sterilization using non-ionizing radiation, that is ultraviolet radiation. Okay. And filtration, we are using microporous filters to achieve sterilization, to separate microorganisms from the sample. Okay. Then chemical methods of sterilization, it includes gaseous methods mainly, and many gases we use for this process nowadays. For example, ethylene oxide, beta-propiolactone, hydrogen peroxide, ozone, carbon dioxide, peracetic acid. So normally the gases used in chemical sterilization, they can be classified into oxidizing gases and alkylating gases. Alkylating gases example, the most commonly used one is ethylene oxide, and others like beta-propiolactone, formaldehyde, glutaraldehyde, etc. And ethylene oxide, it is the most commonly used gas in the entire gaseous sterilization methods. Okay. And the other category is oxidizing gases, that is, for example, ozone, hydrogen peroxide, etc. They carry out sterilization by the mechanism of oxidation. So here is the temperature time specification for various sterilization methods. The first one which we have to remember is the general temperature time specification for dry heat sterilization, that is 160 to 170 degrees Celsius for 2 to 4 hours. For dry heat sterilization, the general temperature time specification is 160 to 170 degrees Celsius for 2 to 4 hours. Okay. So coming to moist heat sterilization, we have 4 temperature ranges to study, and as we see the temperature, as we go down the table, temperature increases, and if we increase the pressure along with this, we can see the time is decreased, time of exposure is decreased. The most important among these is the temperature range of 121 to 124, and the exposure time for that temperature range is 15 minutes at 50 lb per square inch pressure. Okay. So others are also seen in questions these days. 115 to 118 degrees Celsius at 10 lb per square inch pressure, the exposure time is more, 30 minutes. 126 to 129 degrees Celsius at 20 lb per square inch pressure, the holding time is 10 minutes. And for 135 to 138 at 30 lb per square inch, the holding time is only 3 minutes. Okay. But let's have a glance through the different mechanisms of sterilization, that is mechanism of different methods of sterilization. So first one is dry heat. What is the mechanism of dry heat sterilization? Yes, it is oxidation reaction. Okay, coming to moist heat, it is coagulation. Coming to radiation, radiation causes damage to biological molecules of the microorganism, especially to nucleic acids. Okay, then coming to chemical sterilization, we already discussed that there are alkylating gases and oxidating gases. Alkylating gases, example ethylene oxide, very very important. Mechanism of ethylene oxide sterilization is alkylation. Similarly, beta propiolactone, propylene oxide, glutaraldehyde, formaldehyde, etc. Alkylation. Going to oxidizing gases, hydrogen peroxide, ozone, chlorine dioxide, peracetic acid, they are oxidizing gases. Finally, filtration, it is a simple mechanism, separation. Coming to applications of various sterilization methods. This is one of the most important area in the aspect of questions coming for competitive exams. Okay, so we'll see one by one. First is dry heat sterilization. So there is a tip to study the applications of dry heat sterilization. Let's remember them in comparison with not applicable for moist heat sterilization. So what are the things which are not applicable for moist heat sterilization? Those are the things which may get damaged by moisture. Okay. So this makes it clear why oils can be sterilized by dry heat sterilization. Oils, if they get exposed to moisture, they will become rancid. Anhydrous materials, similarly powders, all of this can only be sterilized by dry heat sterilization, not by moist heat sterilization. So what are the other materials that can be sterilized by dry heat sterilization? Glassware. For glassware, we can even use moist heat sterilization, but the best method is dry heat sterilization because moist heat sterilization may cause clouding and alkali precipitation in glass. Okay. So other materials that can be sterilized by dry heat are porcelain articles, metallic articles, paraffin gauze dressing. Remember, generally surgical dressings cannot be sterilized by dry heat sterilization. Why we will see later, but this is an exception, that is paraffin gauze dressing is a dressing that can be sterilized by dry heat sterilization. Generally surgical dressings cannot be sterilized by dry heat sterilization. Then assembled equipment such as glass syringes. So don't think it is suitable for plastic syringes. For plastic syringes, we generally use ethylene oxide sterilization or in some cases radiation sterilization. Okay. So coming to moist heat sterilization, it is the most commonly used method for the sterilization of injection solutions and suspensions. Closures, see rubbers can be safely, most rubbers can be safely sterilized by moist heat, whereas most rubbers cannot be sterilized by dry heat. Okay. Filters, surgical dressings cannot be sterilized by dry heat except paraffin gauze dressing, but all surgical dressings can be safely sterilized by moist heat sterilization. Fabrics and glass. For glass, better method is dry heat itself. Coming to ultraviolet radiation, so thinking about the applications of ultraviolet radiation, it should come to our mind, it is a less energy radiation, less penetrating radiation. So it cannot be used for the sterilization of materials where deep penetration is required. So it is used for the sterilization of surfaces, okay, where no penetration is required. Surfaces like hospital operating room, remove a vaporized hydrogen peroxide, sterilization by ionizing radiations. Similarly, sutures, vitamins, antibiotics and hormones in dry state. So how we remember? These compounds, vitamins, hormones, etc. are thermolabile. If we are sterilizing them by heat methods, they are heat sensitive, they may get degenerated. So we can use ionizing radiation for the sterilization of vitamins, hormones, antibiotics, etc. So remember, ionizing radiation is used for the sterilization of plastic devices, sutures, vitamins, antibiotics, hormones, etc. in dry state. Coming to filtration, again thermolabile pharmaceuticals can be sterilized by filtration. Aqueous liquids, oils, organic solutions, air, other gases, non-terminal sterilization. Why it is called non-terminal sterilization? Because terminal sterilization is the sterilization procedure that is done after the final packaging. Okay. So after, in the case of filtration, we cannot do it as a final sterilization method. That is, if for example it is an injection, if it is packed in an ampule, if we have to do filtration of the injection, we will have to break the ampule. That is not practicable. So it is a non-terminal method of sterilization. Remember, filtration sterilization is a non-terminal method of sterilization. Then pharmaceuticals, to which agents like additives, heparin and vitamins are added after sterilization, post sterilization. All these things we can sterilize by filtration sterilization. So coming to ethylene oxide sterilization. Coming to ethylene oxide sterilization, see, we can sterilize dry powders, plastic, rubber, stainless steel, delicate optical instruments, injection sets, hypodermic needles, plastic syringes, etc. with the ethylene oxide sterilization. So remember, plastic equipments comes under ethylene oxide sterilization. They can be sterilized by ionizing radiation, and plastic syringe by ethylene oxide, whereas glass syringe by dry heat sterilization. So coming to beta propiolactone vapor, we can study its application in connection with the application of ultraviolet radiation sterilization. So you can think in this way that it is both of them, ultraviolet radiation and beta propiolactone vapor. They are used for the sterilization of surfaces where much penetration is not required. See, beta propiolactone vapor is used to sterilize surfaces such as entire rooms. Okay. While we study application, questions do come from an area which this sterilization method is not applicable for what material. So let's just note that point also. For dry heat, what all materials we should not sterilize by dry heat? One we already discussed, that was surgical dressing. So if we sterilize a surgical dressing by dry heat sterilization, it may get overheated and undergo charring. So remember, this dry heat sterilization method is not applicable to surgical dressings. Okay, but only exception is paraffin gauze dressing. And also we already discussed, it is not suitable for rubber, but some rubbers can be sterilized. Remember, silicone and some kinds of chloroprene can be sterilized by dry heat sterilization. So what all materials cannot be sterilized by dry heat? One is surgical dressings, second is rubbers except silicone and chloroprene, and third is cutting instruments. Why? If we sterilize sharp cutting instruments using dry heat sterilization, the sharp edges may undergo oxidation and the sharpness may be lost. Okay, so this is why we cannot sterilize sharp cutting equipments by dry heat sterilization. But in textbook, it is said that scalpels and scissors can be sterilized. So keep in mind both these things. Sharp cutting equipments generally cannot be sterilized by dry heat sterilization, but scissors, scalpels, etc. can be sterilized. Okay, that is it. Then coming to moist heat sterilization, it is not applicable to assembled equipment like glass syringes. Why? In moist heat sterilization, moisture has to penetrate every area of the equipment to make sterilization efficient. But this may not occur. Moisture cannot penetrate to every nook and corner of an assembled equipment. So it is not successful in the case of assembled equipments like glass syringes. Okay. And moist heat is more damaging to glass and metal than dry heat. We already discussed that dry heat sterilization is the best method for sterilization of glass wares. Okay. So finished that topic, that is mechanisms of sterilization, different types of sterilization and applications of sterilization. Now we will see some values in connection with the sterilization. First and most important is D value. So what is D value? It is the time for heat or chemical exposure. See, in the case of heat sterilization method or in the case of chemical sterilization method, for example, ethylene oxide sterilization, it is a time required for the microbial population to reduce by 1 decimal point. That is, initially if there is 100% microbial population and the time required to decrease to reduce by 1 decimal point, that is, initially there was 100%, now only 10%, 90% is loss. So that much time required in the case of heat or chemical sterilization. And if it is in the case of radiation sterilization, the dose of radiation required for the same thing to happen. This is D value and this is the formula for D value. D is equal to U by log N0 minus log NU, where U is that time required and log N0 is the initial number of microorganisms, initial bioburden, and log Nu is the number of unsterilized unit, that is unsterile units. That is the number of undestroyed units at the end of this U time. Okay, so with this equation we will get D value. So these are some other values. These are not much important as D value. Well, let's just see. N0 is the bioburden, Z is the resistance value, F is the sterilization process equivalent time, F0 is the sterilization, another sterilization process equivalent time. So there is some difference between F and F0. Then Nu is the probability of non-sterility, and Nu, that is also known as, that is probability of non-sterility is also known as PNSU, that is probability of non-sterile units. Okay. So going to next section, that is the methods of sterilization by moist heat. This is also an important area. What are the different methods of moist heat sterilization? First one is familiar to all, that is autoclaving. Another method is pasteurization. It is a method used to make milk safe. Okay, then tyndallization, inspissation. They are fractional and marginal methods of moist heat sterilization. Then sterilization of vaccines. Then heating with the bactericide, that is a combination treatment, and hydrostatic continuous sterilizers used to sterilize the sample. Okay. So we will see the important points only. Pasteurization. Pasteurization has two methods. Method 1, first method is the Holder method, and the second method is called the flash method or HTST method, that is high temperature short time method. And the Holder method, the temperature is 62.8 degrees Celsius and held at this, milk is held at this temperature for half an hour, that is 30 minutes, and quickly cooled. So in comparison with the Holder method, flash method is too short. Okay, as the name indicates, it's a flash, that is we are here, holding the sample, holding milk at very short time period only, that is 15 seconds compared to 30 minutes for holding method. This time is very short, we are holding for 15 seconds. So obviously the temperature is a bit high, that is 71.6 degrees Celsius. So remember, the time is more for Holder method. For Holder method it is 30 minutes, but the temperature is less, 62.8 degrees Celsius, whereas for flash method or HTST method, the temperature is more and the time is only 15 seconds. Okay, 15 seconds. Okay. So coming to tyndallization and inspissation, we already discussed the principle of tyndallization and inspissation. Tyndallization is a fractional method where we have to repeat the sterilization process in order to sterilize the sample. So first, on the first day, it is kept at 80 degrees Celsius for 1 hour, and this is repeated on the second day and third day. And this is a useful method for the sterilization of culture media. Remember, tyndallization can be used for the sterilization of culture media. Coming to inspissation, here we are using very low temperatures, that is as low as 60 degrees Celsius. Now heating with bactericide, everyone knows this temperature time combination. It is very important, 98 to 100 degrees Celsius for half an hour, that is 30 minutes. This is the temperature and time for heating with a bactericide. And what are the common bactericides used? That is chlorocresol, phenyl mercuric nitrate, chlorocresol in 0.2% concentration and phenyl mercuric nitrate in 0.002% concentration. Next is sterilization of vaccine. It is nothing but vaccines are biological products, so they will not withstand very high temperatures. So most of vaccines are stable at a temperature range of 60 degrees Celsius. So the sterilization temperature for vaccines will be nearly 60 degrees Celsius. It will not be 60 degrees Celsius. We will be adding some safety factor, that is we will be keeping the temperature slightly below 60 degrees Celsius. For example, we can see for plague vaccine, it is at 55 degrees Celsius for 15 minutes. And for cholera and typhoid vaccine, it is 1 hour at 56 degrees Celsius. Okay, so this time duration is based on the thermal death time. So what is thermal death time? It is the shortest time necessary to kill a population of specified size at a particular temperature. So the thermal death time is the shortest time necessary at a specified temperature to kill a microbial population of specified size. Okay. So coming to different types of radiations used for sterilization. A common question from this area is the radiation having highest penetration power, that is gamma radiation, and it is used most commonly. So let's see the different two types of radiations, that is non-ionizing radiations, ionizing radiation. What are the properties? Which are they? So non-ionizing radiations, they are less energy radiation, less penetrating radiation. Example is ultraviolet radiation. They will not ionize the molecules in the microbial cell. Whereas ionizing radiation, they are associated with high energy. They have good penetrating power and they can ionize the biomolecules. Examples most commonly used one is gamma rays, and other examples are X-rays and cathode rays. Examples of membrane filters used for sterilization. So this is a common question, the pore size of this membrane filter. Mostly two types of membrane filters are used, microporous plastic membrane filters. These two grades are most commonly used. First is millipore type HA. Millipore type HA, its pore size is 0.45 micron plus or minus 0.02 micron. And a more efficient grade, that is millipore type GS, is also used. Its pore size is 0.22 micron plus or minus 0.02 micron. Okay. The most common pore size used is 0.2 micron. So, which are the membrane filter materials used? Most commonly used ones are cellulose nitrate and cellulose acetate. So, along with that, nylon, polyvinyl chloride, that is PVC, polycarbonate, polysulfone, polyether sulfone, polyethylene, polypropylene, polyvinylidene fluoride, polyamide and Teflon can be used. So other filters, actually these filters, they are not very commonly used nowadays because they can shed particles into the filtration medium. So anyway, we'll just remember the names for the sake of questions. Okay, first is asbestos filter, also known as Sates filter. Second is cindered or fritted glass filter. It is also known as Morton filter. Third is filter candle. It is called a Berkfield filter or ceramic filter. And along with them, like them, other sintered metals such as stainless steel and silver can also be used as filters. So coming to gaseous sterilization, there are two types of sterilizing gases, alkylating gases and oxidizing gases. Alkylating gases, as we already discussed, ethylene oxide, beta-propiolactone, propylene oxide, glutaraldehyde and formaldehyde. And oxidizing gases, the examples are hydrogen peroxide, ozone, chlorine dioxide and peracetic acid. So another important area of sterilization is the biological indicators of sterilization. We know what biological indicators are. They are the spores of resistant organisms which are used to monitor a sterilization process. Okay. So coming to different species of biological monitors used in various sterilization methods. First one is steam sterilization. For steam sterilization, we can use 4 varieties of microorganisms. First one is Geobacillus styrothermophilus, Bacillus subtilis, Bacillus smithii and Clostridium sporogenes. Okay. For dry heat sterilization, nowadays only one biological indicators is most importantly said, that is Bacillus atrophaeus. It was previously known as Bacillus subtilis variety niger. In all the question papers, this option was coming as answer, Bacillus subtilis as the indicator for biological indicator for dry heat sterilization. The new name is Bacillus atrophaeus for variety niger. Okay. Then coming to gas, liquid and vapor sterilization, we can see the indicators, biological indicators are common with some heat methods. That is, for example, ethylene oxide sterilization. For ethylene oxide sterilization, it is Bacillus atrophaeus, and for chlorine dioxide sterilization, it is again Bacillus atrophaeus, and peracetic acid sterilization, it is again Bacillus atrophaeus. For ethylene oxide, for chlorine dioxide and for peracetic acid, the organism is same as that used in dry heat sterilization, Bacillus atrophaeus. And the other two gases, for hydrogen peroxide and for ozone, we use Geobacillus styrothermophilus, which is that it is used for the evaluation of moist heat sterilization. So, for hydrogen peroxide sterilization and ozone sterilization, we can use Geobacillus styrothermophilus, same as the organism used for steam sterilization. So, coming to radiation sterilization, Bacillus pumulis is the organism, Bacillus pumulis, and it is not much used now. There are some more examples for biological indicators. For filtration sterilization, we can use Pseudomonas diminuta. So, how we will remember this? There will be minute pores on the filter, no? So, minute, diminuta. Pseudomonas diminuta we can use for filtration sterilization. Then, formaldehyde sterilization, we can again use Bacillus subtilis variety niger. Then for hydrogen peroxide and peracetic acid sterilization, we have already seen some biological indicators there. Along with that, we can use what? Bacillus coagulans and Clostridium sporogenes. Okay. So that's all about biological indicators. So apart from that, there are some physical monitors of sterilization. First is radiation sterilization. For radiation sterilization, we can use a plastic dosimeter as the physical monitor. Okay. So whenever the term dosimeter comes, let radiation dose, that word come to your mind. So dosimeter for radiation dose, that is for the evaluation of radiation method. Dosimeter is for the evaluation of radiation sterilization. So coming to filtration sterilization, there is a physical monitor, that is bubble point pressure test. Bubble point pressure test is used to evaluate filtration sterilization. So coming to chemical monitors. So first one is Brown's tube. It is the most commonly used chemical indicators for heat processes. So what does Brown's tube contain? It contains a reaction mixture and an indicator, and and an indicator, and this reaction, the reaction between the components in the reaction mixture will occur at a specific temperature, and with that reaction the indicator will give a particular color. So based on this different colors, there are different Brown's tubes, type 1, type 2, type 3 and type 4. For us the most important one is that used for moist heat sterilization, type 1. It gives a black spot at 126 degrees Celsius, and type 3, it is used in dry heat sterilization at 160 degrees Celsius, and it gives a green spot. Remember, green spot for dry heat sterilization and black spot for moist heat sterilization. So coming to witness tubes. Witness tube we can remember in this way, as the name indicates, it is a witness. That is, it is a witness of what temperature is achieved in the sterilization process. So it is nothing but a single crystalline substance. What it does nothing, it melts at its melting point. So if the melting point of this substance is the sterilization temperature of a particular sterilization process, it can witness that this temperature has been achieved by simply melting. So this is the principle behind witness tube. And what are the materials, what are the crystals we use in witness tube? First one is sulfur. It melts at 115 degrees Celsius. Its melting point is 115 degrees Celsius. Then succinic anhydride. It melts at 120 degrees Celsius, and benzoic acid at 121 degrees Celsius. So sulfur 115 degrees Celsius, succinic anhydride 120 degrees Celsius, and benzoic acid 121 degrees Celsius are the common crystals used in witness tubes. Next is another indicator called heat sensitive tape. So it is a tape which changes, this tape has many bands on it. That is stripes. Okay, these stripes will turn into a dark color when a specific temperature is attained. And this heat sensitive tape, it is used in Bovie-Dick test. So what is Bovie-Dick test? So it is a test done to check whether steam penetration is even and rapid in all areas in the sample for sterilization. If steam penetration is even and rapid, the heat sensitive tape put at the center of the pack for sterilization will be seen as all its stripes turned into a different color. So this is Bovie-Dick test, and remember, heat sensitive test is used in Bovie-Dick test, and Bovie-Dick test is used to check whether the steam penetration is even and rapid throughout the sample. Okay. Next is Roy's sachet. Roy's sachet is an indicator for chemical sterilization, that is ethylene oxide sterilization. So it too contains a reaction mixture. It is a polythene bag which contains magnesium chloride, hydrochloric acid and bromophenol blue indicator. So if ethylene oxide comes in contact with this reaction mixture, what happens? It reacts with ethylene oxide and gives ethylene chlorohydrin, and the color will change from yellow to purple. So this is all about Roy's sachet. Remember, Roy's sachet is an indicator of ethylene oxide sterilization. Brown's tube and witness tubes, they are indicators of heat methods, and heat sensitive tape is used in Bovie-Dick test. Similarly, dosimeters, they are indicators for radiation sterilization. Bubble point pressure test is an indicator of filtration sterilization. Okay. So chemical dosimeters, what does they monitor? It is radiation sterilization itself, because dosimeter measures dose. So that's all about the most important points in this chapter. We will just see some very few questions and wind up the session. So which is the method used for sterilization of thermolabile powders? Option A, gaseous sterilization. Option B, dry heat sterilization. Option C, moist heat sterilization. Option D, sterilization by ultraviolet radiation. So how we will answer such questions? See, here they have clearly mentioned the material is a powder and it is thermolabile. Okay, so if it is a powder, which method we have studied so far? More than one methods, that is dry heat sterilization can be used. Ethylene oxide gaseous sterilization can be used, and radiation sterilization using ionizing radiation can be used. Okay, but we cannot use moist heat sterilization because it is a powder. Only that is our information. But again, there is a specification. It is thermolabile. So we cannot use heat method. So we will cancel dry heat sterilization. Then we have two options. Moist heat sterilization cannot be used. Dry heat sterilization cannot be used. Then two options are there. Gaseous sterilization or sterilization by ultraviolet radiation. Then think about the penetration power. Whether ultraviolet radiation can penetrate deep into the powder bed? No, it is used to sterilize surfaces. So we cannot use this method also. So the answer becomes gaseous sterilization. So option A, gaseous sterilization is the correct answer for this question. Okay. Next question, which among the following method represents chemical cold sterilization method? Two words are there, chemical and cold. So we'll see which is not associated with the heat and which is associated with the chemical. First one is sterilization using gases. Yes, it is associated with the chemical. Sterilization using filtration, not associated with the chemical. Okay, not associated with the heat also. Next, sterilization using radiation. Radiation sterilization can be, most of radiation sterilization is not associated with the cold heat, except very rarely we may use infrared radiation. Infrared radiation is associated with the heat. So generally we cannot say 100% radiation sterilization is cold sterilization, but most radiation sterilizations are cold sterilization because they are not associated with the heat. We will see the last option also, that is sterilization using moist heat. It is associated with the heat. So both chemical and cold will come where? In which option? Only in option A, that is sterilization using gases. That is the correct answer. Okay. Next question. The pore size of millipore filter GS grade used for aseptic processing. Option A 0.02 plus or minus 0.01 micron. Option D 0.22 plus or minus 0.02 micron. Option C 0.11 plus or minus 0.01 micron, and option D 0.65 plus or minus 0.02 micron. So the direct question, option B is the correct answer, 0.22 plus or minus 0.02 micron. Next, alkylation of protein molecules is the mechanism of sterilization by dry heat, heating with bactericide, ethylene oxide, moist heat. Again direct question, which sterilization method works by alkylation? It is ethylene oxide sterilization. Option C is the correct answer. Next, the method used for sterilization of surgical dressings. Option A, dry heat sterilization. B, moist heat sterilization. C, gaseous sterilization. And D, radiation sterilization. So which sterilization method we studied in the application section as used to sterilize surgical dressings? Moist heat. Dry heat cannot be used and moist heat can be used. So option B is the correct answer, moist heat sterilization. Next question, Holder method is option A method to hold glasswares. Option B, a method to make milk safe. Option C, a method of water purification. So what is the correct answer? Holder method is a method of pasteurization and it is used to make milk safe. So option B is the correct answer. Next question, which of the following radiation is having highest penetration power? Option A, UV, option B, X-ray, and option C, gamma radiation. Which radiation is having highest penetration power? It is option C, gamma radiation. Next question, time for heat or chemical exposure or the dose for radiation exposure required for the microbial population to reduce by 1 decimal point, 90% or 1 logarithmic unit reduction is called option A, D value, option B, F value, and option C, Z value. Answer is D value. Which of the following organism can be used as a biological indicator for dry heat sterilization? Option A, Bacillus stereothermophilus, option B, Bacillus atrophaeus, option C, Bacillus coagulans, and option D, Clostridium sporogens. So which is the organism? We just mentioned that it is Bacillus atrophaeus. Option B, earlier it was known as Bacillus subtilis variety niger. Okay. So that's about today's discussion. Thank you all.